Hey, good morning, everybody. Hey, the F-15s just took off a few minutes ago. That was really cool. Hopefully we'll be able to see them really well when they return around 12:03. Anyway, I'm in my garage here, and I wanted to introduce to you the idea of solubility. It kind of goes along with our unit on molarity. I'm in my garage here, just kind of panning around. It's a little bit of a mess right now. I'm doing various projects. The projects are keeping me really happy. Since I don't have you guys, period one, to be my morning happy here. So anyway, we're going to be doing solubility. So I've got a couple little demos set up, and let's get to that. Now to start with, solubility is a measurement of how much solid chemical can be mixed in with a liquid. Usually the liquid's water, and usually the chemical is some type of a salt. Now remember, a salt is a metal like potassium bonded to iodine. We're used to table salt, sodium chloride, there. And it's kind of cool. Okay, so, sorry, good night. So this chart, this shows the solubilities of various salts. Most of them are salts. Now, this chart you'll be working with, this shows the temperature. Now, most of us, we're going to be somewhere in the mid to low 20 degrees in our houses, okay? So that'll be about where we are. So this chart, you can look at these various salts, and you can see at a particular temperature, how many grams, now this shows right here, how many grams of the solute, that's the solid part, that's the crystals, can dissolve in 100 grams of water, which basically means 100 milliliters of water. And I've put over here, for demos here, I've put these up. There is, okay, so there's 100 milliliters of water. You can see it. These are my wife's stemless wine glasses. Here's 200 milliliters of water. And then I figured out we'll do, there's some rubbing alcohol. That is isopropyl alcohol. It's iso is a chemistry term that means the carbon chain is bent. Propyl is a prefix that means there's 3 carbons in this organic compound. And since it's an alcohol, that means there's an OH group attached to the end. And at some point you may take organic chemistry and there's all sorts. You might have heard of like formaldehyde that they would put stuff in. That's another shape of an organic molecule. Or esters tend to smell really nice, like roses and oil of wintergreen. Those are various organic compounds. Anyway, so I got off track. Sorry. Let's get back to solubility. So just keep in mind, when you're working on this sheet in a little bit, this is going to tell you for every 100 grams of solution, usually water, how many grams of material can dissolve in it at this temperature. Okay. Now, like some of these problems, this one, how many grams of potassium chloride can be dissolved in 200 grams of water? Potassium chloride. Let's see. That's this one right here. Mine got cut off. Potassium chloride. And let's see, what's the temperature? 80 degrees. So you just come over here, you go up to the chart, and at 80 degrees, it looks like, okay, there's how many grams would dissolve in 100 grams of water. Now this problem is saying if you had 200 grams of water, so use this chart to get your first part of the answer, 80 degrees, over to there, and then just double it because this is only for 100 grams. So they'll be pretty straightforward. I don't think there's any other, had you watched the videos about saturation, hopefully you saw the hot ice video that talked about supersaturation. Anyway, let's do our little demo here. So this is Ginger. She, since my wife is off at the grocery store now, she's hanging out with me in the garage. You want to say hi, Ginger?
Hi, everybody.
You want to say hi there, everybody? Okay, cool. Anyway, so I just pulled out a quarter of a teaspoon of this sugar, and I'm going to put it into, let's first put it over here into the water here. Let me sorry, I'm having trouble aiming this. Where's my camera? Oh, it's over there. Okay, gotcha. So that sugar seems to, okay, so it's starting to dissolve. We're all familiar with putting that into there, and it's taking a little bit. So what's happening is that actually the sugar molecules are kind of being broken apart, and they're going to actually end up fitting between the water molecules, believe it or not. And let's see, that looks like it's pretty much dissolved into there. So we haven't reached what we would call the saturation point yet. So I'm just going to put another quarter of a cup here. And now at this point, I'm going to time lapse this So okay, well I've put what is this, 6/4 teaspoons, so that's going to be 1.5 teaspoons so far of sugar, and it's dissolved. I'm not going to keep doing the sugar. Actually will take a lot of it. Now what I'm going to try here, let's put it in this rubbing alcohol over here. So the isopropyl alcohol. Now this isopropyl alcohol, it's not pure isopropyl alcohol. It's got a little bit of water in it too. So this is sugar, and so I'm going to put that into there, and I'll mark this as, okay, there's one of those, and I'll take this out of here. In fact, I'll rinse it off in the one is just plain water there, dry it off of my leg, and let's see here. Now, so this is the rubbing alcohol, and I think we're going to find that rubbing alcohol and sugar do not mix. Now that stuff there, it's not dissolving at all. Well, sorry, you gotta mind what I'm looking at here. So there is basically, well, I can't say there's zero solubility, but sugar's solubility in alcohol is really low. Alcohol doesn't allow the tiny pieces of sugar to live in and around it, and so it just, in essence, the alcohol doesn't let the sugar hang out inside of it, so it just pushes it aside. Oh, sorry, and it falls to the bottom. So this is, you can see there, it's just not dissolving at all. So anyway, sorry, we had so many fun labs to do with this. One of those was going to involve, part of the molarity lab was mixing up Kool-Aid of various molarities and then tasting it. So anyway, you're going to be working on this, and good luck. And by good luck on that, what I mean is, okay, work through the problems, look at that chart, and there was an online lab I was going to have you do, but it needed Flash Player, and it may be kind of a pain. So, hey, I miss you guys, and we're down to, I think now, 23 days to the last day of school. Whoops. Oh yeah, stepping on stuff. So anyway, hang in there, guys. Social distance. I know a lot of people are starting to go out without masks, and just be careful, because the nationwide the trend is increasing. We're still getting more and more people that are dying from this. So be smart about it. I want to get back out there. I want to go out to eat. I know a lot of my friends want to get back to work, but it's not going to do us any good if we get back to work and then die from an infection. So be smart. Take your masks with you. It may not be your life you're saving. It might be your grandma or your grandpa, okay? Or your aunt or your uncle or your cousin. So you got to take this serious. And okay, talk to you later. Miss you guys. Love you all.